Good afternoon to one and all. Good afternoon once again. I welcome you all for the AICTE PRERANA, which is a scheme for preparing SC/ST students for higher education and especially GATE. And today's topic will be about hydraulics and pneumatics. And myself, N.S.MOHAN, belonging to the Department of Mechanical Engineering. I'm an assistant professor. I'm working for Erode Sengunthar Engineering College. So, coming to the topic, we have introduction to fluid power. So first of all, we have to know what is fluid is all about, and then we will be discussing about the various types of fluid available and what are the various things that can be done with the help of this fluid. Okay, so coming to the introduction part. So here is the introduction to fluid power. So fluid can either be a liquid or gas. As we all know, fluid can either be a liquid or a gas. Okay, so liquid in the sense it may be of oil or water. Whatever substances which is present in the liquid form will be considered as hydraulic system, and the gas, whichever the medium that is in the gaseous state, especially air is also a gas. Air contains mixture of gases, and that it is called a pneumatic fluids. Okay, so in general, fluid can be subdivided into two major categories. The first thing is the hydraulics, and the next thing is the pneumatic system. Okay, so hydraulic system is nothing but wherever we are using oil or water in liquid state. Okay, wherever you are using a medium in a liquid state, it is said to be a hydraulic system, and if it is of gaseous or air, we will call it a pneumatic system. Okay, so we cannot just obtain these two mediums, I mean the pneumatic and hydraulic medium, and we cannot use it for converting it into a useful work. Okay, so what we have to do is, the first and foremost thing is, even if it is available in abundance, and even if it is available of no cost. Okay, for example, I'm saying water. So water is available in abundance. Water alone. So water is available in abundance, and air is also, we can obtain it from the atmosphere. So what the thing is, before compressing it, okay, before we are going to compressing it, it cannot be converted into a useful work. Okay, so only when it is compressed, we can convert it into a useful work. Okay, so for such activity, what is the required thing is, we have special equipment called the prime mover. Okay, so prime mover is nothing but the primary movement of air or a liquid. Okay, so prime mover is nothing but the thing that receives the air from the atmosphere or the liquid from the reservoir and compresses it. Okay, the first thing is we have to compress it. Okay, so the compression taking place at the prime mover. Okay, so the compressor may be of different medium. It may be a pump, or it may be a motor or anything. So for making the compressor work, or to make a pump work, what we have to do is, we have to connect it with some electrical things, or any other hydraulics or pneumatically operated things. Okay, I mean pneumatically operated equipment, right? So here are the next point shows that the prime mover can either be operated electrically, hydraulically, or pneumatically. It may be electrically operated, hydraulically operated, or pneumatically operated. Okay, so coming to the next point, then compared with pneumatic system, hydraulic system works more effectively. It is globally accepted that hydraulic system is capable of lifting heavy loads when compared to that of pneumatic system. The one thing you have to note it down is, hydraulic system can lift heavy loads, but the only thing is, the speed is not, it cannot be increased. Okay, that is the disadvantage when compared to the of pneumatics. So pneumatics has also some disadvantages, such as it cannot lift heavy loads, and there is a and the advantage is, it can move rapidly. Okay, for example, if we connect it to a actuator, the movement will be very active. Okay, active in the sense the rapid movement can be obtained. So, so that's the case why they are using pneumatic system in the case in the robots and all. Okay, humanoid robots and all. Most of the movement is carried out with the help of pneumatic system rather than using a hydraulic system. Okay, so hydraulic system is meant for lifting heavy load at low speeds, whereas pneumatic system is meant for lifting low loads in a higher speed. Okay, that is the difference. Okay, the next thing is we'll move on to the next slide. So we have the classification over here. So we'll see the classification in detail over here. So the major classification is hydraulic power and the pneumatic power system. Okay. So hydraulic power system is nothing but only when it is compressed, only when the liquid or air is compressed, it is considered to be as a power system. Okay. So here we have hydraulic power system and pneumatic power system. So hydraulic power system, it uses water or oil. It either uses water or oil for its work. And compared to water, oil is more efficient because of its good lubrication property. Okay, so when compared to that of liquid, liquid provides cooling. Okay, in moving parts, it provides cooling. Okay, and that is why we are using liquid in the case of what to say, cooling mechanism in automobiles and all. Okay, so liquid has the capability to cool down the system, but what the thing is, not only cooling down is necessary, the other thing required is the heat development. Okay, so heat development has to be drastically reduced in the case of a moving system in order to increase its lifetime. So what we have to do is, rather than using water, we'll be using a oil. Okay, so oil has a self lubricating property. Okay, we all know that oil has a self lubricating property. So what the thing is, when compared to that of liquid, it provides a better lubricity, and it also provides some it also reduces freezing. Okay, so freezing also it reduces. Freezing is nothing but the changes in state. Okay, so when compared to that of liquid, I mean water, oil freezes more slowly. Okay, and it also has a good corrosion resistance. Okay, it also has a good corrosion resistance property that has to be also noted down. Okay, so coming to the pneumatic power system, it uses natural air or gas since it is available in abundance. As you all know, the entire atmosphere is surrounded by air, and it contains some moisture and what to say, gases in it, natural gases in it. Okay, so once it can be used. Once if it is used, once the air is used inside the system, a system is nothing but a entire hydraulic system. I'll show you what the system is all about in the upcoming slides. But when it is used up, we can release the air into the atmosphere since it doesn't have any harmful effects on the atmosphere. It doesn't react with the atmosphere. Okay, so what air we are using inside the system, the same air can be sent out without any purification or without any filtration. It can be sent out. Okay, it doesn't carry any toxic substances from the system. Okay. So the next thing is advantages of fluid power. So here are some advantages. The first thing is ease and accuracy of control. Okay, so this is the first and the foremost thing and very important thing. So what we have to do is, what we have to consider in this particular point is, instead of using levers, push buttons, gear assemblies and anything, we can go for hydraulic system so that we can lift a heavy load. For example, a JCB. Consider a JCB. Everyone would have seen what is JCB. So JCB is a heavy equipment. It's an earth moving equipment. So what does it do? The operator just pulls the lever and pushes the lever. According to that, the heavy bucket lifts up and down. Okay, so that is carried out with the help of this particular hydraulic system. Okay, so ease and accuracy of control. Let us see the point over here. Levers, push buttons may be used and can be easily started, stopped, speeded up, and also speeded down. Okay, it can be stepped up or it can be stepped down. Its speed can either be increased or it can be decreased according to the operator's usage. Okay, so the next thing is multiplication of forces. So multiplication of forces has also become easy when compared to that of conventional methods. Okay, the conventional method, what I mean is, here we use some gears, pulleys, and all those stuff are eliminated here when you go for hydraulic system or a pneumatic system. Okay, for example, I have given an example also here: power steering, brakes, and presses. Okay, so power steering in way back in the year of 1990 and all, there were no power steerings available. Okay, so what the thing they used were the rack and pinion mechanism. Okay, rack and pinion mechanism is the basic mechanism for converting the rotation of the gear into a linear motion. Okay, so that is a rack and pinion mechanism. So the gear meshes with each other, right? The gear meshes with each other. So on continuous usage, what happens is it creates backlash. Backlash is all you know. Okay, backlash is nothing but the wear and tear of gear creates some slipping of gears. Okay, that is considered to be the backlash, and that can be eliminated with the help of a power steering. Power steering is completely operated either pneumatically or hydraulically. In general, hydraulic power steering is much preferred than that of pneumatic power system. Okay, the next thing is constant force and torque. Okay, that is very important also. So constant force and constant torque is provided in the case of fluid power. Okay, so simplicity, safety, and economy. Okay, so it is very economical when compared to that of the conventional method. For rather than going with gears and heavy equipments, we can make use of this smaller equipment for doing the same thing. I mean, for doing this, for performing the same action, we can go for hydraulics and pneumatic system rather than using a gear assembly. Okay, so that is what simplicity, safety, and economy means. And safety, coming to the safety, the operator uses these machines can be much safer than compared to that of conventional method of using the machine tools. Okay. Then economic, as I said, the price also is very low. Okay, consists of fewer moving parts, maintenance also less, and high power to weight ratio can be obtained. High power to weight ratio can be obtained, and there are some other advantages too. Absence of vibration. Okay, we can completely eliminate the vibration. The vibration is negligible in the case of hydraulics and pneumatics, and less space requirement. That is also very important. If you go for gears and linkages, if you even if you go for linkages, you may end up in messy operation. Okay, messy in the sense it won't be so neat to use, or it requires much amount of maintenance, and it requires periodic change, and everything has to be maintained in a proper way. Requires periodic change, and everything has to be maintained in a proper way. That thing can be eliminated with the help of eliminated if you are going for hydraulics and a pneumatic system. Okay. So let us see here: absence of vibration, less space requirement, quiet operation. Design is not influenced by geometry. This is the very important thing that you have to note it down. So what the thing is, even if the current mechanism operates with the conventional method, you can automate it with the help of hydraulics and pneumatics. Okay, that is the point. That is the meaning. You can automate it with the help of hydraulics and pneumatics. That is the point. That is the meaning of that particular point. Design is not influenced by geometry. Okay, it means that the geometry doesn't get disturbed when you go for hydraulic and pneumatic system. Okay, for example, you have a shaper machine. You have a shaper machine, right? In your manufacturing technology lab, you have a shaper machine. You would have studied in your MT2. Okay, so what the thing is, the shaper machine works under with what's quick return mechanism. Okay, so quick return mechanism, you have a gear and you have a linkages. Okay, everything you will be having. Okay, that thing can be replaced with the help of pneumatic system or a hydraulic system. So that by using a regenerating circuit or by using a metering circuit, you have metering circuit also. I'll tell you what metering also. With the help of that metering circuit, you can go for automation in the case of shaper machine. So that is what the shaper machine. You are not going to change any construction, or you are not going to change any geometry with in that particular machine. So what you have to do is you are just removing the conventional method. I mean that the with what quick return mechanism, you are totally removing that setup, and that setup is replaced by a hydraulic system. Okay, so that the to and fro motion can be easily obtained. Okay, so the cutting stroke will be slow, and the return stroke will be fast, and that is called as Whitworth's quick return mechanism. The return stroke should be faster. Okay, that can be achieved with the help of hydraulics and pneumatic system. Okay, so I hope this point is clear to you. And coming to the next topic, coming to the application. Okay, so application means where and all we are going to use hydraulics and pneumatic system. So it extends its route in almost every direction. Okay, hydraulics and pneumatic system has expanded its routes in almost all direction. So even in a small industry, for opening a shutter, also we are going for hydraulic system. So see how hydraulics and pneumatic has dominated its place in the current era. Okay, so coming to the application, a muscle power in heavy machine and industry. Okay, it acts as a muscle power. Muscle power is nothing but a very helpful thing in the case of machine in heavy industries. Okay, then in steering and braking mechanism also you have braking mechanism in automobile also we are using for hydraulic and pneumatic system. So coming to have heard about normal hydraulic brakes. Okay, so you know about how disc brake also works. Okay, so disc brakes comes under pumping mechanism. Okay, so that is also coming under your hydraulic system. Okay, so and the launching and landing of aircrafts in aeronautics. Okay, aeronautics in the sense, especially in naval. Okay, in navy for landing and all, they will be using a hydraulic system, and also in the aircraft itself. Okay, the landing gear works under works with the help of a hydraulic system. So this all the applications for of hydraulic system, and also harvesting crops in farming, and it has extended its hands over farming also, so that it helps to cultivate. It helps in cultivation and also for what to say in all aspects in farming. Okay, then used in forklifts and other transportation equipment. Also in forklift, you would have seen forklift. You would have studied in your automobile engineering. Okay, so and forklifts also we have so much hydraulic system arrangements. Okay, then after that used in earth movers JCBs. That also comes under heavy machines. Okay, and other geological work. Geological works includes drilling also. The next point is that. Okay, so even in seabed drilling. Seabed drilling is nothing but directional drilling. They call it in other term. They will mention it as directional drilling. So directional drilling also uses a hydraulic system. Okay, where the seabed is drilled through, and for extracting the crude oil from the ocean. Okay. Then after that, use in robotics and industrial automation. As I said, robotics also uses uses a pneumatic system and hydraulic system. It depends. Okay, either if you are using it for welding operation or some other heavy machine handling operations, you can go with hydraulic system. And if it is for rapid movements, okay, for example, for push and place, pick and place robot and all, you can go with a pneumatic system. Okay, so this is what hydraulic and pneumatic system applications are all about. And before going to the properties, I have to say about some advantages of hydraulic system and advantages of pneumatic system. And at the same hand, and in the other hand, we'll be having the disadvantages too. Okay. So the main advantage of hydraulic system is, as I already said, it lifts heavy loads. It is capable of performing heavy operations, and parts cannot won't get rusted up, or it won't damage the part, since oil has a self lubricating property. Okay, oil has a self lubricating property, and thus the maintenance is much less required when compared to that of a pneumatic system. Okay, so this is the advantage of a hydraulic system. Then the advantage of pneumatic system is we can provide rapid movement. We can provide what to say smooth movement without causing any noise. Okay, I'll say that is also a disadvantage. I'll say it later. Okay, later on I'll discuss about that. Okay, the main disadvantage of pneumatic system is pneumatic system is I mean the main advantage of pneumatic system is um, it can all once it is used, okay, once the air is used, it can be released into the atmosphere once again, so it doesn't cause us any hazardous things. Okay, so the main disadvantage in the hydraulic system is quite messy. Okay, the hydraulic system is quite messy. The leak, if suppose if at all your sealing or your sealant get loosen up or something, it gets corroded up, what happens is the oil starts leaking out. Okay, the oil starts leaking out, and that causes a messy atmosphere. Okay, okay, that is the major disadvantage in the hydraulic system. And coming to the pneumatic system, what happens is the leakage cannot be identified. Okay, it doesn't have any color. Okay, uh, you can identify the oil leakage just by looking onto the system. You can identify where the oil is getting leaked up. Okay, so when in the case of pneumatic system, you cannot identify where the leaking happens. Okay, so that is the major disadvantage in the case of pneumatic system. Okay, so this is what I thought to discuss about, and let us move on to the next topic. We have properties of fluids. So in the properties of fluids, we'll be discussing about gases and liquids, and what is vapor and what is gas. Okay, so vapor and gas is quite similar. I'll just discuss in this slide. Okay, so gas and liquid, the molecular packing of air is much faster when compared to that of the liquid. You all know when compared to liquid, air is the molecular interaction between the molecules is quite far when compared to that of the liquid. Okay, so the liquid, and that's it. Air can be compressed, and liquid is relatively incompressible. Okay, so what they are saying is air can be compressed to a small extent since it is loosely packed, whereas liquid cannot be compressed to a larger extent. Okay, so liquid cannot be compressed into a larger extent. So it means that liquid can be compressed. Okay, so liquid or oil can be compressed, and that property is, we will call it as stiff spring. Okay, I'll discuss it on later on when it comes. I will discuss it about. Okay, the next thing is vapor. So vapor is also a gas whose temperature and pressure is closer to that of the liquid. Okay, so it is, when compared to that of liquid, the vapor's pressure and temperature is much similar. Okay, much closer. Okay, when you heat the vapor, it gets converted into gas. Okay, when you cool down the vapor, it gets converted into water. Okay, so the pressure and temperature of vapor is much closer than that of the liquid, and so steam is considered as vapor. Okay, steam is nothing but steam contains some amount of moisture in it. It contains some amount of water particles in it. Okay, that is so steam. So here they are saying that steam is considered as vapor. Okay, so coming to gas, gas may be defined as highly superheated vapor. I mean superheated vapor. Okay, so when you heat the vapor continuously for a higher for an elevated temperature, what happens is the water molecules gets evaporated, and the remaining is your gas. Okay, so that is what they have discussed here. Okay, so gas may be defined as highly superheated vapor whose state is far away from the liquid phase. Okay, um, it is far away from the liquid, so its temperature and pressure is highly differentiated with that of a liquid medium. Okay, okay. So next thing I want to discuss about is the vapor pressure. So vapor pressure is nothing but liquid when kept in a. I'll just say you. I'll just give you a diagrammatic explanation also. I just want you to listen. So liquid when kept into a closed vessel, it evaporates into vapor and occupies the space between the top of the vessel and free surface of the liquid. Okay, what does it mean is, I'll just close this presentation so that okay, sorry, I'll just present my entire screen so that you can know what I'm doing. So here we have a port. Okay, so hope you all can see a black uh, screen over here. So the thing is, this is the container. Okay, this is the container, and this container is filled with water particles. Okay, this is filled with water particles. Okay, consider this as a closed container. Okay, so the liquid is available in a confined environment. Okay, so it means that it doesn't have any gap in it. So what is vapor pressure is, what happens is, if the red line, red color or aura marks indicates the atmospheric change in atmospheric temperature. So due to the change in atmospheric temperature over the walls of the container, what happens is, this liquid particles tends to change its state. Okay, tends to change its state is nothing but the liquid is, gets converted into vapor and it tries to escape. Okay, the only way to escape is the top portion. Okay, the thing I'm indicating in green color. Okay, this portion is the vacant portion. Okay, the evaporated liquid particles will move up, move up to this space. Okay, space available between the walls of the top walls of the container and the layer of the liquid medium. Okay, so what happens is, since there is no place to escape, since the vapor cannot escape outside, and as I said to you before, it is a confined environment, so there is no possibility for the gases to escape out. Okay, so what happens is, this pressure will get developed up, it will get developed further, and what happens is, it starts creating internal pressure. Okay, so this top layer will get pressured up. Okay, the pressure will get increased in this particular area. Okay, and this pressure is said to be the vacuum pressure. Okay, okay, so I'll just stop my presentation. I hope you can understand. Yes, I think you can understand, right? So this is the vapor pressure. I mean, I said why. Vacuum pressure, I said. I'm sorry, it is vapor pressure. Okay. So the next thing is, I'll just explain you once again. So liquid when kept into a closed container. So you are placing a liquid in a closed container so that there is no possibility for the liquid and also gas to escape. Okay, it evaporates into vapor. Okay, once the change due to the change in temperature, what happens is, it tends to evaporate. Okay, and occupies the space between the top layer of the container. Okay, it tends to occupy the space of the top layer of the container. Okay, between the top of the vessel and free surface of the liquid. Okay, the vapor escapes and it starts sedimenting on the top layer of the vessel. Okay, this vapor exerts a partial pressure on the free surface of the liquid. The free surface is nothing but the top layer. Okay, the bottom layer is contained by the bottom portion of the container. Okay, the top layer is free from. There is a gap between the top wall and the top layer of the liquid. So what happens is, this partial pressure acts on the top layer of the liquid, and that pressure is said to be the vapor pressure. Okay, so nothing. It's just very simple. Putting it into a nutshell, what happens is, it just expands due to the change in temperature, and since there is no place to escape, it again acts as the force on the same medium. Okay, water medium. It acts as, it creates the pressure on the same medium, and that pressure is said to be the vacuum pressure. So I mean vapor pressure. Okay. The next thing is cavitation. So cavitation, consider a flow of liquid into a system. So what you're doing is, you're just pouring water from your water bottle into another container. So what happens is, if the pressure at any point, so only the pouring point is kept open. Okay, so it doesn't. It also happens in a closed thing. Okay, closed container in a confined environment. Okay. So what happens is, there is a small space provided, and in that particular space, what happens is, you are pouring the liquid. Okay, it's meant for only for pouring the liquid. So what happens is, if the pressure at any point of the flowing liquid, okay, if the pressure of at any point of the flowing liquid is equal to the vapor pressure. Okay, already when we have seen about vapor pressure, and that vaporization starts creating bubbles. So what happens is, once these the liquid is poured inside the container with some amount of pressure in it. Okay, when that pressure and the vapor pressure, okay, when that pressure and the vapor pressure becomes equal, what happens is it starts creating bubbles. Okay, so what happens next is when these bubbles are carried by the flowing liquid, flowing liquid to a high pressure area, the bubbles begin to burst, creating high pressure. Okay, so it means that what happens is when you're pouring the liquid, it starts creating bubbles from the bottommost layer of the pouring area. Okay, so the bubble starts to expand and it starts to move upwards towards the open area. And what happens is due to the change in pressure, the bubble starts to break. Okay, the bubbles will break, and that once that breaking happens, another pressure is created on the pouring area. Already the pouring area is subjected to some amount of pressure. Okay, so here the vapor pressure also happens, and and the other another pressure is nothing but the bubbles is carried away on the top layer, and since it's getting breaked up, I mean the thing since the bubble getting collapsed, what happens is it releases some amount of air. Okay, so that air also creates some amount of pressure. Okay, the metallic surface over which the liquid flows is subjected to this high pressure. Okay, so the metallic surface is nothing but the pouring area. Okay, the pouring I didn't mean that the pouring area is not the entry port. Okay, so when you are pouring, where it gets dropped, that is the point. Okay, that is the metallic surface. Okay, the metallic surface over which the liquid flows is subjected to the high pressure, causing pitting action. Pitting action is nothing but the the metal layer, what to say, the metal layer carries some dent in it. Okay, it has some dent, it starts creating some dent, so that dent is known as the pit. Okay, we'll call it as pit, and that pitting action is said to be the cavitation. So hope you can understand. So what happened, what the thing is, we have a container, we have a closed container. In that closed container we have a small opening for the inlet. So through the inlet, what we are going to do is we are pouring the liquid into it. You are going to pour the liquid into it. As you are pouring, what happens is once it strikes the bottom layer of the container, the bubble starts to create. Where when the bubble starts to create, only when if the vapor pressure is equal to that of the pouring pressure. Okay, so the pouring pressure must be equal to that of the vapor pressure, and thus results in the formation of bubbles. And what happens is since the variation in pressure, the bubbles tends to move upwards, and after that what happens, once it reaches the topmost layer, it starts to burst. Okay, so bursting in the sense releasing of air. Okay, so the releasing of air also creates some amount of partial pressure, and all put into together, what happens is it all creates on the area, I mean the maximum pressure is created on the area where the water is in direct contact with the metal. I mean the pouring point. Okay, in that pouring point, a small pit is created. Okay, pit is a small dent is created, and that dent is said to be the cavitation. Okay, hope you all understand, right? So we will move on to the next topic. We have some other properties of fluids also. The first is the density. Density is nothing but the thickness. Okay, so it is defined as the quantity of matter contained in a volume or unit volume of the substance. Okay, so mass by volume. Okay, how much amount of water is contained into the particular volume. Okay, a volume is provided. For example, a container is provided. In that particular container, what amount of liquid you are having, that is said to be the density. Okay, then the next thing is specific gravity is defined as the mass density of the given fluid to the mass density of the standard fluid. Okay, so what happens is, for example, you may choose any type of fluid. Okay, for example, you may choose a petroleum based oil, or you can choose biodegradable, I mean bio based oil, I mean biological oil. So anything you can choose, but that has to be compared to that of the mass density of the standard fluid, and that provides you with the result of the specific gravity. Okay, the next thing is specific volume. The specific volume is defined as the reciprocation of the density. Okay, this and all you have studied in your previous classes a lot of time. Okay, so I don't want to waste time in that. So next thing is viscosity. It is defined as the ability of the fluid flow. Okay, it is nothing but the restriction of the fluid to flow. You would have studied in that way. Okay, so it is the measure of the fluid's internal resistance. Internal resistance is nothing but it has some amount of restrictions to flow. That is said to be the viscosity. Okay, it is the measure of fluid internal resistance to flow at defined temperature and pressure. Okay, as the temperature and pressure varies, the flow also varies. Okay, that has to be noted down. Okay, the next thing is cohesion and adhesion. Okay, the cohesion and adhesion you would have seen in your manufacturing technology one when you are learning it for this one, properties of sand. Okay, we have two types. We had two types of sand, right? We have dry sand and wet sand. That is called as green sand and dry sand. Okay, so that in that area we would have come across this particular topic. Okay, the cohesion and addition. So let us discuss what is given in this particular topic. Okay, so it means that the intermolecular attraction between the molecules of the same liquid. Okay, so for example, I'll just explain you with the help of mercury. Okay, consider a small amount of mercury is in your hand. Okay, so what happens is you are pouring the mercury on the top of the table. Okay, you are pouring on the top of the table. So what happens is initially it splatters up. Okay, it splatters, and what happens is it creates some bubbles all over the table. Okay, so once you push those bubbles all together, what happens is it gets converted into a single molecule. Right? Yes. What happens is these single droplets, these separate droplets, when you push those droplets all together, what happens is it forms into a single medium. Okay, it forms into a single molecule, and that molecule is and that property is said to be the cohesion property. Okay, so when it pour it out, it completely flows out. Okay, there is no droplets or no small amount of water left over in that particular container. Okay, so this is the property possessed by a particular liquid. Okay, so mercury has that property. Every liquid has the property, but mercury has the highest property. Okay, highest cohesion property. So it is nothing but it won't leave. There is higher intermolecular attraction between the molecule. Okay, it is mercury is also a liquid. I'm saying it once again. When you pour it onto the table, what happens is it splatters out, and it results in multiple droplets. Okay, so once you push those droplets with the help of your hand or something, what happens is it combines all together into a single molecule. Okay, and that particular property is said to be cohesion. Okay, it enables the liquid to resist small amount of tensile stresses. Okay, what happens is when you put your hand in a drop of mercury, what happens is it expands. Okay, it expands to some extent, and you take it when you take your finger off. What happens is it tends to regain its original shape. Okay, that is the tensile stress here. Okay, so it is a property of the liquid to remain as one single assemblage. Okay, as I already said. Okay, it tends to remain in a one single package. Okay, that is called as cohesion. Okay, so the next thing is adhesion. Adhesion is much more complex when compared to that of cohesion. So okay, so what happens is the container has an effect in this. Okay, let us see. It is the attraction between the molecule of the liquid and the molecule of the solid boundary. So the solid boundary is nothing but the container we have. Okay, so if you pour water in a cup of tumbler, I mean a stainless steel tumbler, when you pour it on your table, what happens is there is some droplet left in the container. Okay, and that property is known to be the adhesion. So adhesion is the change in what to say, change in the medium. Okay, so when you pour water on a table, what happens is there is some droplet left in the container. Okay, and that property is known to be the adhesion. Okay, so adhesion is medium. Okay, so we have water is a property that is capable of that is capable of retaining the liquid in it. Okay, so that is called as adhesion. Okay, so this is the difference between cohesion and adhesion. So coming to the capillarity. So capillarity is the combined action of both cohesion and adhesion together. Okay, so let us discuss about capillarity here. It is a phenomenon by which liquid rises or drops into a thin glass tube above or below its general level. Okay, you all would have seen about capillary tube in your thermal engineering lab, and even in your lower class. I mean, 11th, 12th class and all. You would have all heard about capillarity. So capillarity is nothing but the rise or drop of the liquid medium. Okay, so this happens because of the combined action of cohesion and adhesion. If the liquid medium contains some amount of adhesion property in it, what happens is it lowers. You can find the U-shaped finishing on the top layer of the liquid. I mean the capillarity tube. Okay, it has if it has a cohesion property, what happens is it remains as a single molecule, right? We have discussed about it. Okay, it tends to remain as a single molecule. So what happens is there is a small what to say race is observed in the capillary tube. So it is because of these two actions. The one is cohesion and the adhesion property. Okay, the next thing is compressibility. All fluids can be compressed to some extent. This is what I was talking about in your previous slides. Okay, so all fluids can be compressed to some extent, and it makes the liquid to act much like a stiff spring. So I have to say about stiff spring. So what happens is um, you would have observed some fly in the case of hydraulic steering and all. Okay, so fly in the sense how to say that it comes into action after a particular time. Okay, if you turn your steering, what happens is it remains constant. It doesn't change its direction for a particular period of time, and after that, if you turn further, it starts working. Okay, that is the difference between that is the fly. That is the action that actually causes a much damage to the system. Okay, so that has to be eliminated. So coming again to the topic, a stiff spring is nothing but it has some amount of compressibility. All liquids have some amount of compressibility, and especially liquid. What happens is when you compress the liquid, it tends to compress, and what happens is when you release out the pressure, when you take off the pressure applied on the liquid, what happens is it tends to regain its position. Okay, so that is called as the spring. The springing action is available in that particular liquid. So that is called as stiff spring. And the coefficient of compressibility is the fractional change in the unit volume of the liquid per unit change in the pressure. Okay, so there is a change in pressure and change in the volume. So that can be given as compressibility. C is given by del V divided by del P. Okay, so del V is the change in pressure, and V is the initial pressure. I mean the original pressure, and del P is the change in. Del V is the volume, and V is volume. I'm sorry. So del P is the change in pressure. Okay. The next thing is flash and fire point. The flash and fire point we have already seen in your thermal engineering labs and all. Okay. So flash point is the minimum temperature at which the vapor ignites if a source is given. Okay. So what happens is in a minimum temperature when a gas or when a vapor is ignited, that is called to be the flash point. So fire point is something different from flash point. So fire point is the lowest temperature at which the fuel continues to burn for at least 6 seconds after the ignition is done. Okay. So once the ignition is done, it has to burn or it has to put out its flame for about 6 seconds. Okay. So that is said to be the fire point. Okay. So there is a difference between flash and fire point. Okay. So the next thing is this is the basic hydraulics. Today we'll be discussing about the basic hydraulics alone, and I'll just say about what is basic pneumatics also. And in the next classes we will be seeing about what are the various types of prime movers and pumps available in this particular topic. Okay. So here in this diagram you can see some basic things, some basic requirement for designing a hydraulic system. So first thing is your reservoir. So here you can see a reservoir. So reservoir is connected to a filter, and then a pump, and an electric motor, and then a pressure regulator. And here we have control valves, and finally an actuator. Okay, so we'll discuss this about. We'll discuss it each one by one. Okay, the first thing is the reservoir. The reservoir is nothing but a container where here we are talking about hydraulic system. So we are gonna use oil in this container. Okay, so oil is used in this container. So what happens is you can see there's a closed loop system. Okay, see here is the intake and here is the outlet. So once the liquid is used by the actuator, again it's sent back to the container. Okay, so what does it mean is it is a closed loop system. Okay, there is no release of hydraulic oil into the atmosphere as in the case of pneumatic. Okay, so we are going to release it into the reservoir once we make use of that particular compressed oil. Okay, the thing is filter. Okay, this thing I wanted to talk about. Okay, so as I said, it is used in a confined environment. Okay, since it is used in a confined environment, there is no possibility for dust particles or any other solid substances to get entrapped in this particular reservoir. Okay, so still, why you are using filter is the system has some amount of dust particles. Doesn't mean that dust particle due to wear and tear. What happens is when the oil once used returns to the reservoir, it carries some solid material in it. Okay, so that solid material has to be filtered. Okay, so since the pump is very precision instrument. So what happens is if in case we are not using the filter, these solid particles enter into the pump and it damages the pump. Okay, pump is the costliest material in this particular topic. So what happens is the pump has to be maintained in a proper manner. The proper maintenance has to be done. So what happens is in order to filter all those solid material and all those dust particles, what we are going to do is we are dealing it with filter, and after that once the oil is prepared, I mean, oil is free from a dust particle, it is sent to the pump. Okay. Here the pump is operated through a electric motor. Okay. So the pump is actuated by a electric motor. So once the motor rotates, the pump rotates. So pump is, we have a number of pumps. We have internal gear pumps. We have external gear pumps. We have low pumps, vane pumps, and gear pumps. We have a multiple number of gear pumps. Okay, so that multiple number of pumps should be actuated with it contains some amount of what to say heavy medium in it. Okay, heavy medium is there present in this particular pump. So that pump has to be actuated with the help of electric motor. Okay, so the electric motor is the drive. Okay, here is the drive mechanism available. So this pump is a driven. Okay, so M is considered as drive and P is considered as driven. Okay, so the pump is driven by the motor. Okay, right. So next it goes to the pressure regulator. Okay, so the pump creates some amount of pressure. It increases the pressure, and when compared to that of reservoir, when it is contained into a reservoir, what happens is it doesn't have that amount of amount of pump. I mean pressure in it. So in order to increase the pressure, we are going for pump. So pump increases the pressure, and even if it increases the pressure, if the system doesn't if the system requires more amount of pressure, okay, what happens is this pressure regulator increases the pressure. Okay, so the pressure outside the pump is if it is somewhat less, what happens is this regulator takes the responsibility for increasing the pressure, and after that it transports it into the valves. Okay, we have valves here. In valves also we have a number of valves. Okay, we have direction control valves, we have pressure control valves, and pressure relief valves also we have. Okay, so this is a type of 3x2 direction control valve. So here they are using a direction control valve. So what we have here is here in particular we have a 3x2 direction control. Why I am saying 3x2 is we have three positions. Okay, here is the rise position, off position, and the final one is the lower position. Okay, so we have three positions and we have two outlets. Okay, we have two ports over here. Okay, so one is the inlet port and another one is the outlet port, and vice versa. Okay, so we have three positions: off position, rise position, and lower position, and we have two ports. Okay, one is the A port and another one is the B port. So first thing is we have to lift the medium. Okay, it is a type of actuator, and also talking about the actuator, we have two types of actuators. One is the linear actuator and another one is the rotary actuator. And here in this case, we are going for linear actuator, cylinder, and whatever the thing that performs a linear action, it is considered to be the linear actuator. Okay, here in particular we have a cylinder, so it provides a to and fro motion, and that is why we are considering it as a linear motion. Okay, I mean linear actuator. Okay, so what we have is we have two ports. One is the inlet port and another one is the exhaust port, and we change the direction of the lever. This becomes the inlet port and this becomes the exhaust port. Okay, so first thing is we are entering the liquid into the port A. So what happens is the weight lifts up. Okay, the weight lifts upwards. Since the pressure is higher in this case, I mean in the port A. So what happens is the weight is lifted up. Then what happens is when you turn off, what happens is it just stands still in that position. Okay, so when you pull the lever on the other side, what happens is the liquid enters into the medium through the other port. Okay, here For the first thing, if you want to raise, what happens is the liquid enters into the actuator through port A. Okay. In order to lower this, what we have to do is we have to reverse it, so that we have to pull the lever on the either side, so that the water, I mean the liquid or the oil flows into the port B, and the weight moves downward. So this is the movement happening here. Okay, so let us see what are the things available in this particular hydraulic system in detail. Okay, so these are the basic components of a hydraulic system. The first thing is reservoir or storage tank. It is one that holds the hydraulic fluid which would be useful in the system. Okay, which is used in the system, used by the system. The next thing is filter. Filter is meant for purifying the fluid and make it free from impurities. So every impurities has to be removed from the filter. As I said, even if it is a closed environment, there is a possibility for solid waste matter to get entrapped in the system, since the moving part is available. Okay, actuator is a moving part, so there is a possibility for heat development and sedimentation of due to wear and tear. There may be some solid part sedimentation. Okay, so filter is employed for that, and we have a prime mover. So prime mover is the one which makes the pump to draw the fluid from the fluid and deliver it to the actuator for performing a usual work. So next the thing is the pump. The pump is to convert the low pressure liquid into a high pressure liquid. Then we have pressure regulators. So pressure regulator is responsible to maintain the flow of pressure. So what happens is, even it is a hydraulic system or a pneumatic system, no matter what, the pressure has to be maintained as per the requirement. Okay, if the pressure increases, it may cause severe factoral damage to the entire system. Okay, so we have control valves also. So in that particular control valve, we have direction control valve, flow control valve, and pressure control valve, and we have pressure relief valves also. Okay, it is also a type of control valve that has to be made into consideration. Okay, then finally the actuator. Actuator, we have rotary actuator and linear actuator. Right. So next thing is we'll discuss about the pneumatic system. Okay, here we have the pneumatic system. So in this case, what happens is, the only difference is it is not a closed loop system. See, here there is an exhaust. It is not a closed loop system. So, in addition to that, the reservoir is replaced with the compressor over here. So, first thing is we have a reservoir. Reservoir is nothing but a compressor. Okay, so we also have a compressor. So the next thing is the compressor, the prime mover, valves, actuator, and piping. Okay, so air is filtered. So if we are not using filter here in this particular part, we can put the filter here. Okay, we will call it as an FRL unit. Okay, here they have mentioned FRL unit. FRL unit should be placed in front of the what to say in between the compressor and the system. Okay, so I'll say what is FRL unit and for what purpose we are using for we are going for FRL unit. Okay, the first thing is filter is also available in compressor itself. Okay, let us consider like that. Okay, so filter is available in the compressor. So compressor contains some high pressure air within it. Then high pressure air is supplied to the FRL unit. So FRL unit is nothing but filter, regulator, and lubricator. Okay, it is a filter, regulator, and lubricator. So what happens is, the filter eliminates the solid matter. I mean, it prevents the solid matter entering into the pneumatic system. So it is also available in the compressor. So okay, the air when compressed has to carry out, I mean, has to carry some amount of water in it. Some amount of oil in it. So that oil is responsible for lubricating the moving parts. Okay, so that has to be done. And the next thing is we have a storage reservoir. Okay, storage reservoir. Why we are using here? In case of power failure, there is no possibility for the weight to stand stagnant in this particular area, since the air leakage is high when compared to that of hydraulic system. Okay, so what happens is, there is a possibility for air to leak when the weight is applied without any support. Okay, so what happens is, in order to eliminate that, we are storing a pressurized air in a container, which we will call it as an accumulator. Okay, so this and all we will be discussing in the next class. Okay, so this is the FRL unit. I mean, this is the pneumatic system. So this consists of a compressor. A compressor is the essential component that sucks the air from the atmosphere. And FRL, we have already discussed filter, regulator, and lubrication. So it helps in order to maintain the lifetime of the moving part. I mean, especially the actuator. Either it may be a pneumatic, I mean, linear or a rotary actuator. The next thing, the prime mover. The prime mover is here is also a motor. Then we have pressure regulators, and which is responsible for maintaining the pressure. And control valves, the same thing. The same thing that we saw in the case of hydraulic system we discussed. And finally, the actuator. Actuators also, we have two types of actuators. One is the linear, and the other one is the rotary actuator. As per the requirement, we can make use of it. Okay. So in the next class, we will be seeing about the classification of pumps. We have some dynamic pressure pump. Dynamic pressure pump is, we can call it another name like non-positive displacement pump, and also we have displacement pump. Okay, I mean positive displacement pump we have, and we'll be discussing about these topics in the next class. Okay. Okay, thank you very much for your patient listening. So we'll see in the next class. Thank you for attending the class. Okay, so next class we will be handling it with types of this one types of pumps. Okay, thank you.